Good afternoon, everyone, and warm welcome to ERTICO's Friday's webinar. Today's webinar is about Smart City IoT, and the subtitle of this webinar is Smart City of Tomorrow. My name is Vlad Vorotovic, and I work for ERTICO as Senior Manager. And for this webinar, I invited three of the colleagues to talk about how Smart City of Tomorrow would look like. So this is the lineup for today. I hope you can see now my colleagues. So just a brief introduction for each one of them, and then each will have an opportunity to present their views, ideas, and the work of their companies. And then at the end, we're going to talk and have a question and answer session. So I have today with me Rob Capaldi from Horgo Myra, commercial manager with in company since 2013, working on connected and autonomous vehicles. So Smart City of Tomorrow does include connected vehicles and automated vehicles. Then the other participant who will speak after Rob is Milos Milisavljevic. He's the founder and CEO of Strawberry Energy. And Strawberry Energy disrupted street furniture and created smart city furniture. So you're going to see more and hear more about that a little bit later. And the last but not least speaker is a program manager from TNO from Netherlands, Jeroen Bos. So I will do a quick introduction of ERTICO, as always, a couple of slides, mandatory slides of the moderator, and then we're going to listen what these guys have to tell us and have a question and answer at the end. So ERTICO exists since 1991. And over these years, ERTICO became a hub where different organizations, institutions, public authority come together to work on common topics. And I'll show you those topics that connect all of us. On this slide, you see the network of ERTICO partners. And on the left-hand side of the slide, you see that we have a number of public authorities as partners of ERTICO and working with us very closely. The second sector we cover and have a good representation in ERTICO are the research institutions in Europe and globally. We have service providers, we have OEMs, we have users or representatives of the users, and experts in traffic and transport industry and suppliers. Since ERTICO started so many years ago with 15 partners, now there are about 120 partners in our partnership. The four topics, the four focus areas of ERTICO and what we work and where we work, where we focus, are presented. And as I said, part of the Smart City of Tomorrow, of course, includes connected and automated driving. So that's one topic, and you will hear a little bit about the project that ERTICO is involved, and also work that Rob is doing in Horgo Myra. The second topic we are involved, it's very important to us. It's clean mobility. It is effectively the whole sustainability agenda and topic. And speakers like Milos and Jeroen will tell us a bit more how they address clean mobility and also urban mobility, how their products and services represent these focus areas that ERTICO is quite interested. The last topic we cover, not least, is transport and logistics. So we are involved in a number of projects on this topic. At the moment, ERTICO is working on 23 European projects, and I'll present briefly one of them. One other thing that it's a really recent activity that ERTICO has done, and it's gaining a lot of interest across the industry. Being a hub, connecting various institutions, organizations, and people, we actually realized that we can offer our services in education and training. So we created ERTICO Academy. So this is a little flyer. What we do through ERTICO Academy, you can see examples of some of the training modules, such as the ITS, CITS, Mobility as a Service, Digital Freight, etc., etc. And if you're interested to know more about ERTICO's Academy and how you can participate, please follow the link at the bottom of the page, ertico.com/academy. As I mentioned, there are 23 projects that we are currently involved, and one of them is ICT for CART. This is an EU-funded project looking at the connected future for automated vehicles. Again, I put the web page there, so if you want to follow up and find out a little bit more. This is the scope of the project. What we're trying to achieve as one of the members, you will see there are quite a few members and quite a few European states involved. Again, it is the topics of today's webinar and the connectivity and the IoT, Internet of Things, and how the infrastructure and the vehicles within that infrastructure are communicating, and how we can push the boundaries, how can we implement technological advances. Of course, how we can link up other projects of similar scope and objectives. In this sense, for instance, what you're going to hear a little bit later from Rob, he will talk about projects that Horvo Meyer is involved in this space. So this is some facts and figures about the project itself. ICT for CART, 21 partner, 10 million funding, 3 years duration, and 9 European countries. And the partners are represented by their logo on the right-hand side of the screen. And as I said, every project we are involved, every work, all the work we do is trying to reflect those topics that I mentioned, the 4 focus areas, and also 3 key things we are trying to do through our work, to integrating and connecting and creating a bridge between the industry, the research, and the cities and public authorities. How we can make our cities nicer, more efficient, safer, sustainable. So impact on the environment, improvement of traffic flows, improvement in our mobility solutions and transport provision. Again, every project we do is has a focus about research, innovation, development. So we are trying to see how we're impacting the market and how we're pushing the market together with our partners. So some of the impacts are listed on market itself. And then very importantly, and we will talk again a little bit later, it's the safety, how we can reduce the accidents on our network, both between vehicles and active mode, etc., and how we can really improve the mobility services and boost innovation in the best interest of public. So these are the topics and the projects that we are involved, and this is where I want to introduce now my first speaker for today, continuing the topic like this project is starting, but from the perspective of Horvo Meyer, who are in West Midlands in the UK. So from West Midlands in the UK, Rob Capaldi. Hello, Rob.
Many thanks for the introduction, Vlad. So hopefully my screen is now shared. So I'm going to be talking today about connected and autonomous vehicles. Horvo Meyer are a leading automotive engineering firm based in the UK, and the perspective that I'll be bringing to this presentation is that from the engineering community involved in the development of autonomous vehicle systems to understand the safety implications, what security is required to ensure that these vehicles are operating correctly. And I'll talk around the industry and the development trends that we're seeing. And finally, what we are doing as a company to help serve this market. The automotive industry underwent its first great revolution with the development of assembly line manufacture, moving from hand-built one-off vehicles to efficient mass production of products for a consumer market. We're currently going through the second great revolution as we see an increase in adoption of new fuel types to reduce the use of fossil fuels and reduce harmful emissions from internal combustion engine vehicles. We expect to see that the third revolution will come as there is a significant shift in not only the technologies fitted to vehicles, but also how those vehicles are used, with highly automated vehicles being developed to serve completely new use cases, with ride sharing and mobility as a service being seen as a key future vehicle use case within a smart city. As an automotive industry, we're currently seeing that our development direction is being shaped by 4 key megatrends. The fact that in future mobility will be connected, automated, shared, and electrified. Governments around the world are preparing for this future and are heavily invested in this developing trend. The US government is actively engaging in the preparation for an automated future. The Federal Department of Transport have published many papers and guidance notes to help shape the way these technologies will be trialed and finally implemented on US roads. And communications are becoming a key part of their research, with many projects focusing on the trial and development of new technologies in this area. The UK government has established a department, the Centre for Connected and Autonomous Vehicles, with the specific brief to establish the UK as a leading global location for the development of CAV technologies. They'll develop an inclusive regulatory framework to allow the trial, development, and then implementation of CAV technologies on UK roads. They'll fund innovative research into CAV technologies, and they're developing CamTestBed UK, a network of testing organisations administered by an organisation called Zenzik to provide a network of testing facilities to validate these technologies, everything from core vehicle requirements all the way through to communications technology and the flow of data. The Society of Motor Manufacturers and Traders, the industry body that's well recognised as representing the automotive manufacturing sector, has estimated that by 2030, 1 in every 5 miles travelled by consumers could be automated. This figure was published in their Connected report published in 2019, and they very heavily cite the fact that advanced communications technologies will form part of the enabling infrastructure to allow this target to be realised. So in order to enable these advances in technology, we're seeing an increase in the complex electronic systems and communications technologies fitted to vehicles. In fact, embedded electronic systems are set to account for around 50% of the material cost of vehicles in the coming years. The car is shifting from being a personal mobility device to becoming your biggest consumer electronics purchase. Connectivity takes many forms, with many different data applications built into the on-vehicle systems, including navigation, communications, security. Connected services are even starting to influence vehicle behavior through cooperative connectivity, with information provided either by infrastructure or from other vehicles. We can classify the communications technologies fitted to vehicles in 2 areas. Number 1, for safety-related features, the trend is to use vehicle-to-infrastructure communications using technologies such as SATA 211p, ITSG5, DSRC, Wi-Fi. These technologies, low bandwidth, low latency with high propagation, are very good for safety critical messages to influence vehicle behavior. Number 2, cellular data typically can offer much higher bandwidth required to send large amounts of data, but the corresponding high latency in the network means it's unsuitable for safety critical uses that require fast decision making. For automated vehicles, the range of technologies fitted and the roadmap to their implementation is very widely published, with a combination of on-vehicle systems being developed by vehicle manufacturers, growing from advanced driver assistance systems through to the higher levels of autonomy. The timeline for implementation of these is widely known and is on course based upon many industry recognized roadmaps. Traditional OEMs following the path that you can see on screen with a stepped approach, combining many features together to move from driver assistance through to full automation. It shows that there's a long-term trend towards automation. Even in the short term, there's an increased level of functionality, which is having an impact on the validation and verification requirements. We're starting to see disruptors move into our industry who are taking a revolutionary approach, jumping straight into the development of high levels of autonomy. Although they're developing technology in a different way, the validation challenges that they face are very similar to the challenges that are faced by traditional automotive manufacturers. This represents a multi-sector challenge. To deliver autonomous mobility as part of a smart city requires integration. It would not be possible for mobility as a service to exist as part of a smart city if vehicles operate independently of infrastructure. The challenge is to enable the use of these vehicles as part of the overall city system. To enable this cooperative system, there are a number of key enabling steps that are required. Firstly, infrastructure. it's responsibility of the network providers, the infrastructure providers, to provide the wide range of communications technologies to enable this information to flow between cities and vehicles. Having safe, functional and secure vehicles is the responsibility of the automotive industry. The car manufacturers, vehicle makers must ensure that on-vehicle systems are developed to provide a safe and reliable user experience. Local authorities and regulators are required to provide a legislative framework that allows these business models and technologies to operate. They must provide a welcoming environment to enable the trial and further deployment of the technologies on the public road. And finally, perhaps one of the biggest requirements to enable these technologies to be uptaken on the public roads is consumer acceptance. We all have a responsibility to demonstrate that safe systems are safe and reliable, to give users confidence that they will provide a service that will improve their lives.
Rob,
so when we start talking about
just a quick question actually that prompted me, and I wanted to say also to the participants, the audience, that you can ask the questions using the portal on the right-hand side. So type in the question and send it to us. We can answer throughout the talk and obviously later. Rob, you mentioned safety and security, and City of Tomorrow. How Horda address things like cybersecurity and making sure that nobody can hack the vehicle that is in the City of Tomorrow?
So cybersecurity becomes one of the real key technology areas that needs to be addressed. And actually, I've mentioned that the Centre for Connected and Autonomous Vehicles in the UK is looking to establish the UK's position as a leading nation in the development of these technologies, and cybersecurity forms a key part of their future roadmap. There's recently been a round of investments in a series of feasibility studies to look into the specific requirements for the ongoing development of cybersecurity in the UK. Myra has been part of a project called ResiCav, looking to develop the requirements and specifications for a vehicle security operations center that will support the monitoring of the demands of the forthcoming ISO SAE 21434, and it will extend the application of artificial intelligence and data visualization techniques. This project will develop the requirements for a UK Centre of Excellence to support the UK's position in meeting the challenges of automotive cybersecurity. And we'll continue to be involved in this project and the ongoing projects that will establish these centres in the UK.
Thank you.
So to carry on, we started to talk about connected autonomous vehicles, and there are two different things mentioned in that title, both connected and autonomous. When we talk about connectivity, there are different definitions of connectivity and the influence that connectivity has on the vehicle systems. And we can see a build-up in how the vehicle consumes data and provides information out into the smart city. So stage one is connection, where real-time data is provided to the vehicle for information purposes, such as map data, traffic data for use in navigation systems. We're all familiar with using Google Maps for navigation, receiving dynamic updates on route planning based upon congestion and traffic flow in certain areas. Following connection, we look for vehicles to cooperate with peer-to-peer communications between multiple vehicles or between the vehicle and the city infrastructure. This is now used to improve the efficiency of journeys and to ease the congestion in busy areas, rather than simply trying to avoid it through the connected information. This could include prioritization of traffic signals or cooperation between vehicles to establish a platoon to improve fuel efficiency over a long journey. Finally, we combine these systems with the onboard vehicle actuation systems to control the vehicle behavior based upon the surroundings and the information provided to the vehicle. Some examples of cooperative vehicle applications that are currently in trial are shown on screen here. One of the most widely trialed systems is Green Light Optimized Speed Advisory, GLOSA, which is one of the most trialed uses of this technology to optimize the flow of vehicles through intersections by reducing the need to slow down for red lights, either modifying the vehicle speed or modifying the signal phase and timing of the traffic lights to improve flow through junctions. Platooning is where multiple heavy goods vehicles operate together to form a land train to share improved fuel efficiency through controlled speed over long journeys. Collaborative parking is the ability to navigate directly to open parking spaces to minimize unnecessary travel behavior hunting for a parking space. And finally, emergency vehicle warning, improving the visibility of emergency service vehicles within vehicle warnings to supplement the visual and audible warnings from sirens and lighting. All of these technologies are currently under trial and being applied in many locations around the world. So as these increasingly complex systems become more prevalent, how do HORIBA MIRA address this complex challenge, and the complex challenge that is the validation of these CAV systems? Firstly, we consider safety. We're building upon 30 years of experience in developing and delivering both passive, active and functional safety projects with a team of many engineers meeting the challenging and complex demands of the next generation of mobility. We apply industry recognized functional safety tools from ISO 26262 and SOTIF to ensure hazards are fully assessed and mitigated as part of the development process. We combine this with security, building upon 12 years of experience developing and deploying automotive cybersecurity. Finally, we ensure the functionality is correct, building on decades of experience in developing vehicle systems and nearly 20 years experience in the development of connected and autonomous vehicle systems. We support our clients to create and deliver development plans that ensure all requirements are met and the systems performed as they're designed. The pyramid that's shown in the center represents the specific requirement to validate the systems across all of these points. How do we support our clients to deliver the development of these requirements? Through the integration of a CAV test ecosystem. We are investing heavily in the development of a range of test facilities and capabilities that will enable all aspects of the validation challenge to be met. These are represented by the points that you can see around this circle, all of which are linked and form a continually evolving circle that needs modification and evolution as we go through the development cycle. So we start with simulation and modeling, enabling the validation of systems at the very early stages of development, and also supporting the ongoing need to validate a statistically representative sample of test scenarios in a repeatable way to a very high volume throughout the development process. We have a number of controlled environments replicating edge case test scenarios likely to be seen by the vehicle in a variety of settings. Our urban environment replicates a city. The network of roadways and junctions is supported by high levels of connectivity provided by ITSG5 communications, a controllable cellular network, and configurable signaling infrastructure. This allows us to verify a large number of smart city technologies, not limited to just the vehicle as a standalone piece of the puzzle. Within our urban area, we're developing a controlled parking facility, enabling us to trial the specific use case of an autonomous valet park system. Not only the on-vehicle systems that enable the parking of the vehicle to take place, but also the back office infrastructure to validate the parking transaction is complete in line with the physical parking maneuver. This is vital to city operators and parking providers. And the physical location of this facility will be within our urban environment, within the city location, to enable us to test the vital last half-kilometer use case as the vehicle navigates through the city to the parking area and then completes the parking maneuver. We will be able to trial vehicles at the limit of their handling capability on a large and highly controllable facility. Our dynamic platform will allow us to create complex test scenarios for high-speed maneuverability to ensure vehicles are able to react safely to the demands placed upon them by the complex automation systems, and to allow us to test vehicles at the limit of their capability, injecting faults to see how the dynamic performance of the vehicle reacts to these unexpected changes and unexpected demands. Cybersecurity remains an ongoing requirement, and we're making significant investment, as already mentioned, in the test requirements, the facility requirements, and the ongoing position in the UK's direction for development of cybersecurity. Finally, public road-based trialing is an important piece of this set of requirements. We have access to the Midlands Future Mobility network of public roads, which form part of CamTestBed UK. In fact, these public road network leave from the front gates of MIRA, so we're able to complete all aspects of these testings from one location, from simulation modeling through the controlled environments and out onto the public road, allowing a truly unique proposition that addresses all of the key elements of the complex challenges to ensure connected and autonomous vehicles are safe, secure, and meet their functional requirements. That's the end of my presentation, and welcome any further questions.
Thank you, Rob. Thank you. Quite a few interesting points and the whole cycle that you are applying in HORIBA MIRA. Horrible, Myra. And we have a question that maybe you can answer, think about and answer from the audience. What about future governance of the connected transport system? Who will control the data? Because we spoke about that, and you mentioned telecom operators, ICT companies, OEMs, or government, or all of them. What's the position on the market with regards to control the data?
That's one of the really big questions, and it's something that there's an awful lot of work going into at the moment to try and understand who's responsible for data. There are different perspectives from this. The automotive perspective on data is that the data collected is highly important as part of the development of their products. Therefore, there's a certain need to protect that data and ensure that it remains confidential. The flip side to that is the government perspective, where there's the need to understand how users are behaving, how they are operating within the transport network. There needs to be a balance that is found between those two, where the automotive industry are able to use the data for development purposes, but the regulators are able to use it from a regulatory and from a usage monitoring point of view. And there's a lot of work going on at the moment to try and find where that happy balance sits. At the moment, there isn't a clear answer as to who is actually responsible. One of the other challenges that exists around that is simply the volume of data that's likely to be created. One of the figures that I've seen publicized is that an autonomous vehicle is likely to create 4 terabytes of data in a typical day. The management of that volume of data and how it is transmitted is a significant challenge that needs to be addressed.
Yeah, I have to praise in the UK, at least, the Parliament and House of Lords actually had a really good initiative of call for evidence with regards to these topics, where they invited industry experts to present their views and evidence on all of these pressing issues, and then to see how they can address this topic through regulations. It would be good if audience which we have, which is coming all across Europe and actually the world, somebody may ask the question or actually comment what's happening in their country or region. Thank you, Rob, for this. We're going to move now on the next presenter. So I invite Milos to show on camera. And now this is an interesting story. And actually, Rob mentioned disruption in his field. And what about if you disrupt something like street furniture, smart city furniture, benches, smart benches powered by solar panels? And that's an idea that started some time ago, which Milos will tell us. And I was actually impressed to read that currently 30 plus cities, 37 or 8 cities across 17 countries have smart benches. So hello, Milos, and please tell us more about Strawberry Energy and your smart benches.
Hello, hi. It's a great pleasure to be here, and thank you for inviting me. So basically, just to give you a short bio on us. So in Strawberry, our goal is to help create smart cities with a special focus on our public spaces. So our core mission in Strawberry is to help improve our public spaces to make them more responsive and more useful, more beneficial to our needs in the 21st century. So as Vlad, as you said, we've been around for some time. We are present actually in over 50 cities in over 22 countries, everywhere from like the Mexico and the US to Australia and Middle East. And we are changing our public spaces one smart bench at a time. So I think we got a very kind of good impression of what's happening in the car industry, which I think is one of the most important pillars of this big thing that we call smart cities. And I would like to jump into something that we hold dear in Strawberry, which is improving our social connections and public spaces, which is very interesting in the time where we live now. The kind of like where it all starts was that actually when you look around yourself, and this is true for any city in the world, when you look around yourself in the cities, you will see that actually our street furniture didn't change much in the last almost 100 years. So the payphones, the phone booths are the same as they were 100 years ago or 50 years ago. Our street lights are the same as they were 50 or 100 years ago. Our benches are the same as they were 1,000 years ago. So we definitely thought that actually by reinventing, focusing and reinventing of these pieces of street furniture, we can actually help bring IoT and bring these new technologies to the public space for the benefit of both citizens and local governments. And that's what we are doing in Strawberry. So our main goal was to start reimagining smart street furniture to make it more useful and more beneficial. And of course, there is a bunch of different things that you can look around. But as you can see here, we identified 3 pieces, the bench, payphone, and the bus stops as the first kind of product portfolio that we in Strawberry started working on. And I would like to jump in now straight into a smart bench. So what is actually a smart bench? So the smart bench basically is a completely solar powered social IoT hub, where we basically, when we focused on this, we said, what is actually the most common piece of street furniture and that you can find anywhere in the world, and how we can make it better. And the bench stood out, not just as the most common piece of street furniture, but also the piece of street furniture that has the biggest social component, where people are most likely to engage in their everyday journey through the city. And we started literally looking at the bench as a technology hub. What we can do with the bench to provide a value and help people have better experience and better quality of life in their local surrounding. So we equipped the bench with a solar panel to provide completely green solar energy so that the benches also can have a good environmental impact as well. We started adding basic features like charging for any portable device, for your phone, tablet, headphones, your smartwatch, whatever it is that you can charge these days. So you can charge all of those things on the bench using solar energy. Then we added Wi-Fi to provide also a free Wi-Fi in the area around the bench. And when we combined those two, energy and connectivity, we actually realized that we created an IoT platform. We created a smart city platform in the bench that's going to be beneficial not just for the people sitting on the bench and using these facilities, but actually can be useful for any third party that would love to deploy their technology in the public spaces. So then we actually started adding additional features to the bench. So for example, we added a complete set of air quality sensors to measure local air quality levels in the real time. We added contactless payment modules to help, for example, local charities raise more money, where people can just go to the nearest bench, tap their card, and donate £2, for example, to cancer research, which is a project we did in London. And we, for example, also added artificial intelligence, basically AI, into the bench through integration with Google Assistant and Alexa to effectively create like an info desk, like an information hub of the bench, so people can ask relevant local information. When is my bus coming? How do I get here? What is the working hours? Where I can find good burgers, and so on. So this is just to illustrate some of the areas where we started developing the bench as a smart Internet of Things hub. Of course, one size and one design cannot fit all. So that's why we started developing a portfolio of the benches. So I just basically took 2 of the benches, the first one and the last one actually, to showcase that it can also be smaller, because we realized if you want scale, if you want to bring this to as many places as possible, you'll need something smaller that you can easily ship to wherever it is in the world and have it ready without installation, without technical maintenance, to be even more simple bench. And this is, for example, one of our latest designs that's already available and I think ready to use operationally in over 20 cities. So the idea with the bench, of course, was to not just be the bench, but also to be an IoT hub, to help provide more benefits and more value to different areas that we like, to our parks, our campuses, our shopping malls, our riversides, wherever you have ordinary benches. Then we basically started partnering with different cities. So we continue developing the product technology, but then we also try to be innovative in how we can scale this technology further. So we started partnering with cities in a very kind of unique way, where we said in a specific cities like London, like Belgrade, and now we are working on Munich and Milan, we basically started partnering with cities to provide them the benches completely free of charge, and then to use them basically as some kind of innovative communication medium to offer brands completely new way to communicate with people, to not just to advertise in a regular way, but to do something that's going to present them as a good and responsible brand, but actually do something very tangible for the local community. And that's the project, the world's first network of smart benches that we launched in London 2 years ago. And we started then expanding that throughout London and throughout the world. So this is actually a little bit obsolete slide, but now we are working in partnering with different cities around the world to basically help provide this smart city infrastructure as a free service to the city.
Milos, sorry, a question pops into head, which is kind of similar to Rob's, really.
Yeah.
You connect the network of benches, Internet of Things, a lot of data, a lot of communication and connectivity. What about cybersecurity? Can somebody hack the bench to misuse the infrastructure? What's your view on?
Yeah. So there is because we are a physical infrastructure, we actually have a few things to worry about, not just about digital privacy, but also about physical privacy of the bench, or actually kind of like security of the bench. So when it comes to the digital part, that I guess is probably your main point of concern, we are using all of the industry standard encryption level. We are using all of the kind of very let's say standard off-the-shelf technology for all of the communications, so that we can be sure that we are basically safe and ready to use. So even though that we as a company are basically an R&D company and we are developing the benches from scratch, for all of these sensitive parts, we are basically trying to partner to use kind of latest standards, industry standards when it comes to the data and when it comes to any kind of security issues. So those are the parts where we partner with bigger partners that are credible. For example, all of the data that we have on the benches is encrypted and sent to the Amazon servers, so that we basically are piggybacking on all of these kind of big partners like Amazon and similar to that. But when it comes to the physical, basically security of the bench, we are also using as much standards and safety measures that we can, to give just a kind of let's say, to give a easy example for people to understand, and then if there's additional questions we can jump into it deeper. But for example, for the bench to be completely safe to use, we had to completely not use any of the easily breakable materials. So the whole bench is made of steel and stainless steel and thick wooden parts, so that there is no easily breakable materials. The solar panels are protected by thick levels of acrylic glass, very thick levels of acrylic glass that you cannot damage, so that, for example, the bench can be as let's say safe to use, even more, for example, than a car, because on a car you can break a window, but on a bench there isn't anything that you can easily break. So, and we've been around for 7 years now. We've been deploying the benches in over 50 cities globally, and I'm proud to say that we had 0 breaches of any kind of internal tech, both when it comes to the physical side of the bench and the data as well.
Thank you for that. Greetings from Thessaloniki for you, praising your work, that your smart bench was an inspiration for the work they've done in Thessaloniki. But actually the question I just asked, they were asking because unfortunately the bench was vandalized. So this is probably the engagement piece that, and maybe to the rest of your presentation, I can see that you have a vision. So carry on and then tell us how we explain to the people what we're trying to do here.
Yeah, so basically this is actually my last slide, just for kind of to know where we are with the progress. So I wanted just now to zoom out to, for example, some any of our cities basically a couple of years from now. And to basically, we kind of like, I of course borrow this slide, but basically I wanted to kind of overlap some kind of the smart city, typical smart city vision, and to just then provide an example of how the bench or the smart payphone or the bus shelter, for that matter, it's basically the technology that we are developing would be applicable in all of those things, how that would actually interact in a wider smart city kind of vision. And that's something that we call Strawberry Smart Streets vision. So we can say, for example, we can imagine like a random day in a given city, and let's say we have like it's 7 a.m. in the morning, and Mark is going to work. So the smart lighting switches on when he walks by and then switches off where he goes further, which basically helps save the carbon emission, save the electricity, save the money for the local government, and have a very good benefit in that regard. So when it comes then to maybe later in the day, maybe it's like 11 a.m. and Eva has an appointment in town and she's looking for a parking. It's usually a hassle to find parking, but for example, if we equip all of the parking spaces on our streets with the parking sensors, and then we use the nearby smart bench as a gateway to basically communicate, that parking sensor can communicate through the bench, through the local area networks, communicate to the internet, and then to your app to actually communicate to you where is your closest available parking, so that you save your time and actually save again carbon emissions in going into the circles to the city center and easily find the parking. And maybe then later in the day, Tom uses electric vehicle of some kind. So again, by using, for example, an app or integrated into the car, he can go to the closest connected charging station, and if it's connected in a way that it also have a communication channel, you can get information directly. Or maybe if it's just electric outlet that doesn't communicate with you, then again it can communicate with the bench, and the bench with its own connection can bring the data to the server, to your provider of the app, to help you find and book your electric charger spot. And then, for example, we've seen in some areas, we've seen smart bins, smart waste containers popping up, which is basically a very simple container with a sensor inside that measures how the container is full, to optimize waste collection. So again, when it comes to that part, usually all of these services need some kind of secure communication gateways that economically doesn't make sense to put in every single bin everywhere in the town. So again, the bench can be some kind of a local hub that serves as a gateway to all of the connected pieces of street furniture that doesn't make sense to invest so much money into the connectivity, power, and everything else, to basically collect the data and to provide it to the relevant local services.
Yeah.
And when it comes to, for example, weather stations, we've seen, for example, trends so far that the weather stations are very scarce resource still in our cities, and that even a big cities like London can have less than 100 weather stations. So that's why we put air quality sensors and weather sensors as a kind of a complete default option on every single bench that we ship, to understand the local weather and environmental quality conditions, so that we can use the data, for example, about the rain and about the sun intensity to provide that information to the automatic watering, so that local government can water our green surfaces efficiently and just when it's needed. Or we can use that same data to provide you the healthiest route for your bike ride or for your running, if you're interested in that. Or we can use basically that instant monitoring to provide instant update, so that people can get warnings if there is a crash or anything happens, that we can basically have a connected public spaces with the connected street furniture that's designed around improving our experience and safety and quality of life in the city.
Milos, we'll pause you there now, because this is actually a great introduction and a bridge to the next speaker. So thank you. And Yaron comes from TNO. I always consider TNO as sustainability champions because the work they've done with their platforms on analyzing sustainable solutions in smart cities was quite impressive. And then Milos mentioned in the smart streets vision other devices that obviously communicate to each other through IoT networks, and TNO has that as well. So in a sense, we can think about and dream about that. What Rob was talking about, the vehicles talking to infrastructure, they may talk to the infrastructure that Milos and Yaron also has. So Yaron, please tell us a bit more about your work and vision.
Thank you so much, Vlad, and thank you very much for the bridge, because that's excellent. There seems to be a very good connection. So I will talk a little about our smart city solution and about the platform to basically get a grip on what is happening in a city. And let me see if I can go to the index there. First, I will show one or two slides on TNO, what we are doing, who we are, then the context in which we are working, and then I would like to zoom in quickly in, well, where we are working on our roadmap, but then urban strategy, the platform that Vladimir was already referring to, how we build digital twins with this technology, with urban strategy, and how we connect these digital twins to real-time data. And there we come to the smart public nodes that Milos was already mentioning. So this is the basic setup of my presentation. And well, to start, the mission of TNO is well, basically to innovate and to de-risk innovation. We do that as well as on the public side as on the private side. Although we are governmentally funded from the Netherlands, we are independent and really between government, business, and academia, trying to improve the quality of life in society, sustainable quality of life, and to improve the competitiveness of industry. And we do that in many different sectors, and 9 different units covering 9 different topics. We are quite big in defense, safety, cybersecurity, energy, all relevant topics. Me, myself, I'm from the unit Traffic and Transport, and that is basically where we come from. Our unit Traffic and Transport is doing research, applied research on vehicles, everything that moves basically, apart from airplanes. We do that along 2 main roadmaps, sustainable mobility and smart mobility. And Rob was already telling about, well, the smart vehicles becoming more and more automated, becoming more and more connected. We do research on that on the vehicle side. We do research on that when you put it on the road in a fleet, on the street, how you can organize it there. But my program, I'm program manager at TNO, is mainly about what is the impact on the societal level if you bring all these technologies together, and what do cities look like. And that is basically the context in which we work, because we work mainly in a highly urbanized context where the population is growing, leading basically mainly to a scarcity of space. Every city council will recognize that every topic ends up in a scarcity of space, different activities competing for space. While cities have to remain vibrant, meaning they have to remain accessible, sustainable, livable, and equal for all. So that is where the, well, basically the public business case is. But you also see a big transition already referred to in mobility. Well, the digitalization, the data economy, mobility as a service. You could say the platform economy, where the providing a service and owning the assets is sometimes decoupled, really meaning something for the business cases in cities. Higher levels of automation. If there are situations where you get the driver out of the vehicle, this will certainly very fundamentally change business cases in mobility as well. And the energy transition, electrification, also has a big impact on how we use and how we organize space in cities, but it also influences, again, the business cases in logistics and in mobility. So all these transitions affect the public and the private sector very profoundly, and it's happening quite fast now. As Rob was mentioning, many governments are preparing for that. And I won't go into detail but of this roadmap that we are working on, but this is basically the roadmap that is underneath my program. And what we say is, in order to balance the private business case where everybody wants to get from A to B at the lowest time cost and at the highest comfort, we have to balance that with that public business case where we basically have it sustainable, accessible for all now and in the future. And that tension, to get that grip on that, on these two sides of the same metal, we need scientific progress, you could say, developments in different lines, from the tension between urban mobility and environment, traffic safety, the impact of mass, connected and automated mobility, and zero emission mobility. What we do, the instrument that we have to get a grip on this complex situation, on this complex matter in cities, is what we call urban strategy. And what urban strategy does is bring together data, different levels of data in the city, bring it together with very fast simulation models. You can see that in the abstract architecture in the right lower corner. We connect the data layer with different simulation models. We made these very much faster than what the current state of the art is, thanks to GPU technology. And we put them in a framework so these different modules can communicate with each other. Basically, you could say we created a professional SimCity. You can play around with what is happening in the city, add new functions, add different propositions when it comes to mobility, add new functions, close roads, change the infrastructure, and see what the impact is on accessibility, on traffic flows, but also on noise and air quality. And we can really interact with that, and we apply that in different cities, of course in the Netherlands, but also in different places around the world, as you can see in this picture. Coming from mobility, we have a very strong focus on mobility demand and the impacts around mobility. But of course, if you want to create a holistic view, an integrated view of what's happening in a city, if you want to understand the air quality in the city, for instance, you also have to take into account the contribution of industry and households, for instance. So we also have modules and models for that.
Jeroen?
Yeah, please.
I just got a question, and it is related actually to your previous slide, in a sense. Because you can see here a number of people interacting with the platform you have created. And the question is how we collaborate and talk to the citizens to shape our vision, to engage the people. And the engagement was mentioned earlier as well. In this example in Thessaloniki, people need to understand what we are trying to portray, what is the vision. Yep. And I know you are working in a number of cities in Europe and internationally. So is this something that is in an engagement exercise, what we see here?
Very much so, yeah. I'm sorry, I'm going a bit quickly through the slides, but exactly what you say. What we are talking about is complex matter. When you look at traffic or air quality alone, these are, you could say, complex expert matters. And still we want to engage citizens from the level of the citizen to the level of the mayor, because they all have something to say on this complex matter, and they want to interact and they want to understand what is happening, and they want to understand what will happen if they take certain measures. So most of our effort goes into conveying how do you say the outputs, the effects of these complex models, of this knowledge, to different domains and different levels of decision making, and basically simplify the interaction with different stakeholders, so we can jointly shape the vision. That's a very important part of what we are doing. Moreover, what we do is we don't provide an out-of-the-box solution. We say with a city, we start a cooperation. We don't sell a solution. We're not a software selling. We're not a private company doing that. But for instance, with Amsterdam or with Singapore, what you see here, or on the right top, you see the island of Curacao. We are very closely engaged with the local governments and working together with them, trying to understand the problem together and using our solutions there.
Great, thank you. Thank you very much. Yeah, it does, okay, definitely. Okay. Yeah, thank you. Okay.
So this was a slide where the different topics that we address. So it's from mobility, environmental impact, but also, as I mentioned, the impacts of the energy transition. What I left blank, because we are working on that currently, is the impact on road safety if you have a transition in mobility. Well, that's under development. And as I mentioned, we are working together with cities. This is an example of our work in Amsterdam, where basically the mayor of Amsterdam came to us with a question. The city is growing within the city boundaries, so a densification of functions. We cannot increase the infrastructure here, so we have to find ways to deal with that. Can you help us with that? And there we together with the different layers of decision making, together with the different silos in Amsterdam, we started cooperating, and we started to elaborate different scenarios to deal with this urban growth, basically. The next step is that from planning, we go to real-time data and real-time management, if you will. We're not there yet. And one of the examples we have there is, I forget one slide, is we have the technology, we have the ability to connect real-time data to the modeling, to the set of models that we have. And because we have made them so fast to be able to interact with them, we're also able to connect them to real live data streams. And that is something that we applied in the city of Antwerp, where we connected the modeling of the city, 3D modeling, to sensor data, so you get a live digital twin, as you like.
Okay, and you have also a slide or two to tell us about those IoT nodes. Yes, smart public nodes. Exactly. This is the connection with what Miloš's vision is, isn't it? That we are interconnected, and the infrastructure is interconnected.
Exactly, and what we say is, well, if you want to measure, for instance, air quality, that's a societal business case. I mean, you can easily argue that it's useful to get more insight in air quality. But a big challenge that we saw is that because it's costly to build this infrastructure, you also have to build your business case. So basically combine the societal value to values that make money, such as applications such as parking or energy saving or higher efficiency. So apart from the technology, apart from what you do with the data that you get out of it, it's also important to think of the overarching business case, because if you try to solve it in one silo, we found out that it's very difficult.
You will fail. You will fail.
You will fail. Yeah, exactly. And if you build it, the business case, over the different silos over a longer term, then we see that there can be a positive business case. I'm a bit, how do you say, cautious how I formulate, because it's difficult.
Yeah.
And that is basically the conclusion of my story.
Smart City of Tomorrow, that's right. May I invite now the other speakers to switch on their cameras? So this is the Q&A session. And I will just give me a second. Okay, show my screen. Because we have received a couple of questions. One is simple to answer, but people like what we talk about. So the question was, is the recording of this webinar available afterwards? Yes, it is. If you registered, you're going to get the link, and we will promote more for the people who couldn't make it. But yes, you will be able to see later. The question I have for all panelists really is, I see the flow and the connection between different solutions and products you're developing. So what are your views, how you can connect? And Yaron already started, because he started reaching towards the millers. Can we see, for instance, Rob, that tomorrow infrastructure for the connected autonomous vehicles will be talking to benches and light columns in the city, for instance?
Yeah, I think it's essential, and that's one of the things that I tried to highlight in the presentation, is that we can't develop any one of these technologies in isolation, whether it's vehicles, whether it's benches, whether it's smart trash cans. They're the future connected smart city. It needs to be one working, evolving organism that provides information between all of the different nodes. That could be as simple as a trash can needs to be emptied, therefore a signal is sent to a control center, which dispatches a vehicle to go and empty the can. So there needs to be a connection between all of the different points within that.
Yeah. Milos, anything you want to say on that topic? Any discussions you had in the now 50+ cities that you are working with your smart benches and network of smart benches?
Yeah, so basically I completely agree. And like, for example, the big trend that's kind of almost synonymous with the smart cities is 5G, and we somehow managed nobody to mention it so far. Actually, it was mentioned in Rob's original presentation, but the thing is that, for example, we also see a great potential. The major challenge when it comes to the deployment of 5G is that the frequency of the small cells and the cells will be higher than we have with the current technologies. So we see, for example, when it comes to our own vision, we see that the benches and all of the other pieces of street furniture that we are working on will be an amazing small 5G small cells that, for example, will be then crucial to provide all of these 4 terabytes of data connectivity to any car that passes by, because you wouldn't be able to transfer that anyway differently than through the 5G.
And one thing I have to ask, as somebody who has a background in traffic management, traffic control, will this infrastructure, or the approach rather, declutter the infrastructure in the cities? In Rob's case, if we have a vehicle that's intelligent enough to communicate with certain pieces of infrastructure to get information, let's say green and red lights, then maybe we don't need a traffic light, because the other parts of the city will be sensing and telling, the people walking will be sensed, etc., etc.
In an ideal world, yes, and there's also the potential for in-vehicle signaling, where you don't have to have the signaling on the roadside, but the signals come in vehicle. But that is a bit of a utopian dream. I think it was the actual implementation of that is a significant challenge, and it's probably quite a long way away. But the potential for it to happen is definitely there.
Yeah, and actually that's a good point, because we need to consider humans in the whole picture. We sometimes technophiles will create the ideal world, but we need to know that human will react to that. And there was a question which I want to address, which is about the relationship of acceptance of people towards the connected or autonomous vehicles, really. And what are your views, kind of, maybe Rob and Yaron can tell us, because you engage a lot on that topic.
I think it's one of the points that I raised was that the key barriers to the implementation of autonomous vehicles, one of the most important ones is user acceptance. And I think that everybody that's in some way involved in this industry has got an element of responsibility to engage with the public and to demonstrate that the vehicles are safe. I speak to a lot of people about autonomous vehicles, and one of the first things that a large percentage of people say is, I wouldn't get in an autonomous vehicle. They simply don't trust them. There is a lot of work that needs to be done to show people that the systems are safe, and that actually in certain use cases they can be safer than human drivers. And that's really our responsibility to show that that's the case.
More questions are coming. Sorry, go on.
Well, it's the user acceptance, but also the acceptance by the governments. When you look at the situation in the United States, basically the government says, well, if it's not prohibited, it's allowed. In Europe, we have a different way of working there. We have the road authorities allowing specific vehicles on the road. And what we see is that, well, especially in the Netherlands, I know for the Netherlands, Netherlands is a bit reluctant to allow different concepts that are hard to grasp, especially when they are connected and being updated all the time, so you don't know exactly what is on your road. But before we reach that point, it's very difficult. It will take a time to allow them, so to say.
And more questions. Sorry, we are already over the limit, so maybe just a couple more minutes, because we sparked interest and now there are questions coming up. So how is societal versus private interest manifested? Where does regulation or private interest are involved? So the balance between the two, the society and the private interest, I guess in the smart city of tomorrow and everything we talk about, and human acceptance to the technology.
Well, what we see is that especially local governments are struggling with that. When you look at, for instance, new mobility concepts, take a very simple example as a shared bicycle or a step scooter. Basically, what you see is that you have a proposition that is very good for the individual. You get from A to B cheap and very, but it's a business model that it's been run on a public space, and sometimes it's very difficult for the local government to keep a grip on what is happening there. So there you see very eminent what is happening in that balance. Let alone if you would take that from the step scooter to an autonomous vehicle running a proposition.
And micromobility is the prevailing trend now. In last couple of years in the new mobility concepts, and actually now it's getting almost a renaissance or new revolution, rather, evolution, etc. with this the situation we are all now living in, where we have to keep the distance between us. That's the necessity, that's the constraint. And actually maybe a question for Milos. Did you have any interactions with the micromobility providers that your smart bench becomes also a hub for micromobility concepts and scooters and etc.?
We actually did. We were approached by a few scooter companies to actually see if we can provide a charging facility for them, because the major issue with there is a lot of benefits and kind of like everything else connected to the scooters, electric scooters that we see almost in every city now. But the major issue is you don't have any charging infrastructure, and especially if it's your scooter, you will charge it at home. But if it's a public scooter of any kind, there isn't literally a place to do it. So then, yes, we are working on that, and we will have an option, like an optional add-on for the bench that will enable you to charge your scooter.
Yeah, excellent, thank you. And I'm receiving questions on my phone of the people who are also the audience as well on the GoToMeeting. So that's quite cool. People are interested to know more about the modeling and simulation happened in West Midlands, but also obviously it was mentioned in Yaron's presentation as well. So Rob, and this is my kind of topic, my interest as well. So of course people are asking me that.
Yeah, so we get involved in simulation and modeling at lots of different levels when it comes to autonomous vehicles, from a city level all the way down to individual vehicle system level. From a city level, we're very much involved in modeling traffic flow, looking at impact analysis of new mobility types, new vehicle technologies on the existing traffic models. So we've been quite experienced in building models of parts of the road networks that are being designated as test beds in the UK, and looking at what the impact analysis or the impact is going to be of the different transport types and the trials of the autonomous systems on them. And we're also, from the other side, looking very much at vehicle modeling and understanding how the systems of the vehicle perform when you put them into new test scenarios, and looking at novel ways to link the two, where we can make sure that the vehicle information that's being provided into the transport models is accurate and represents the behaviors of those vehicles at quite a high level, whether it's from an autonomous system point of view or even from a efficiency and performance point of view. So when you look at the large scale traffic models for emissions and fuel consumption and such like, you can be confident that the vehicle data that's driving those outputs is correlated closely to actual vehicle data. We get very much involved in that, and it's a key part of the future development of these technologies. So we'll see a continued increase in simulation and modeling of these systems as part of not only the sort of initial proof of concept, but as part of the final validation of the systems as they become increasingly complex and increasingly integrated into reality.
And Yaron, yeah, you have something to say, I'm sure, on that topic.
Yeah, I hope, is my connection still up? Yeah.
Yes, you are. We can see you. We can see you.
Okay. Yeah. Yeah. Of course. It sounds very interesting to make the connection there, Rob, because as you have seen, we as well are modeling from the vehicle level up to the system level, including the environmental impacts of mobility. And yeah, would very much like to make that connection.
Excellent. Okay, final question. We just received it, and it is about, are we going to have more available public space if we deploy this technology, or we just going to reshape it? Which is related maybe to my slightly utopian idea of decluttering. But
can I say something about that?
Yeah. Okay. Yeah.
We have run some simulations on that, and what we see, if you do not regulate it from a public perspective, the proposition of a self-driving car, for instance, will be so good for the individual that you basically will clog up the system in cities, and that is what we already see in the US with the Ubers and the other TNCs. So somehow you have to have a fair way of compensating for the use of public space in order to keep a grip on that. That's basically our story, and then it can help shaping the cities in an accessible and sustainable way.
Milos, now from 30 to 50 cities. So I'm sure you are facing these questions because you are helping the cities to reshape the public space. So and it seems it's going well.
Yeah, it's actually hard because this kind of decluttering is a major trend in almost every city, where they tend to have less of things on the street when it comes to the street infrastructure, not the cars and stuff like that. So that's why, for example, what we are trying to do effectively is to aid that, not to combat that, is to integrate as many different things that otherwise you would have on a multiple points into the single thing. And then for that even single unit that you would have to have there, not to be some new thing that you would put, but maybe some just like removing an old bench and putting in a new one, removing an old bus station, putting in a new one that will actually integrate more features in itself, so that actually will be able to liberate more partial services otherwise.
Excellent.
But yeah, decluttering is probably the major trend when it comes to public authorities.
Yeah, well, you can see I'm coming from the public sector as well, so yeah, my thought went there. Okay, if this was the real panel and we are in the physical environment, this would be thank you very much from audience and myself for participating. It was really a pleasure to talk to you. So many ideas, some great work. So many thanks. And one thing I want before we close, just to mention to the audience and you and keep on talking, is that on Wednesday next week, so not Friday because it's a bank holiday in parts of Europe, on Wednesday at the same time, 3 to 4 European time, we're going to have head of mobility at IKEA and a chief sustainability officer of Sweco, talking with my colleague Alexandra May on sustainability topics and clean mobility that ERTICO also tackles. I want to hear what IKEA has to say and head of mobility at IKEA on that topic. So I think that would be really cool as well. Thanks again. Have a lovely afternoon and weekend, and talk soon.
Thank you. It was a pleasure.
Thank you.
Thank you.
Thank you all.
Bye bye. Thank you. Bye.
Bye bye.